I am Dr. Abhishek Sharma, Associate Professor, Electronics and Communication Department in Chandigarh Engineering College, Nagpur. So today we are going to discuss the very crucial technology and which is very popular nowadays, that is optical fiber communication. So let's start. Following are going to be the content outlines. We will discuss that what is the difference between optical communication and optical fiber communication, because there are two terms. Next, we will discuss that why we need this technology and why you should attend this lecture. Then I will tell you that what is the history of optical fiber communication and how optical system evolves. Then I will tell you that what is this optical fiber, what is the structure of this optical fiber, what are the types of optical fibers, and finally we will come to what are the advantages and disadvantages of optical fiber communication. So let's begin with optical communication. So optical communication basically a mode of communication in which the data will be transmitted in the form of light. As you can see that we have, for example, a satellite and we want to communicate on a earth station and we are using light as a medium. In our daily life, we know that there are wires in our homes, and the signal that propagates through that wire is an electrical signal. But we can communicate with very high speed, with very large bandwidth, if we can replace that electrical signal with this light signal. We will see many advantages of this optical communication system. So optical communication, also known as optical telecommunication, is a communication at a distance using light to carry information. It means your whole signal will be in the form of light. Next, the second term is optical fiber communication. So we can say that optical fiber communication is a further branch of optical communication in which we will use a optical fiber cable as a medium. The light will be transmitted inside this optical fiber cable. So there are two types of mediums. One is unguided, in which there will be air as a medium between transmitter and receiver, just like your mobile phone. Your mobile phone is not connected to any wire, but still you get signal. And on the other side, you can see there is a cable TV in your home. Your cable TV is connected with a cable. So that will be a wired communication and your mobile phone will be a wireless communication. So same is with this optical communication. We can use a laser light and photodetector, and air will be the medium between two, and signal will be transmitted from laser light in the form of light to the photodetector. On the other side, we can connect that laser light with one end of this optical fiber cable, and this optical fiber cable will be used to carry light from transmitter end to the receiver end. And on the receiver end, we will use a photodetector which will convert that light into electricity. So fiber optic communication is a method of transmitting information from one place to another by sending pulses of light through an optical fiber cable. And here you can see this optical fiber cable bundle. Out of this is an optical fiber cable. I will come to the next slides that what its structure is and how we can transmit data through this optical fiber. So, before going ahead, we should know that why you should attend this lecture. What is the advantage? Why optical communication? If we have a electrical communication, then why we are switching to a new technology? Then there are two reasons for that. One reason you can see from this slide that in approx telegraph was used. But if we see the BL ratio, means data rate distance product, BL product ratio, then it was very less, of the order of hundreds bits per second and kilometer. What is this BL? BL is bit rate distance product. It tells you about that up to how much distance we can transmit our data with how much bit rate. Bit rate is, for example, I want to transmit 8 bits in 1 second, then it will be a 8 bits per second will be bit rate. I want to transmit it for kilometers, then bit rate kilometers. So it will be used as a quality of our communication, means up to how much distance we can maintain a particular bit. Then developments takes place and we got telephones around 900. Then in that systems, still it was of the order of thousands BL product. Then coaxial cables were developed around 1940s. Then the data communication rate was further increased. Then microwaves were used for communication around 1954-1956. Then it was a further enhancement in the BL product. But when we switched to optical fibers around 1980s, then you can see there is a huge development in BL product. And then with the invention of wavelength division multiplexing and now space division multiplexing, we can further increase the distance up to which we are transmitting our signal without using repeaters. And the data rate is of the order of terabits per second. So it means that using light as a communication medium, we can further increase our BL product. We can transmit more and more data because bandwidth is more. We can transmit our data to long and long distances of the order of 10,000 kilometers or even more. Now this was the one reason that we should shift to optical communication. Now second, very important for you, that is the job areas in this sector. Can you imagine that how many companies are operating in India today? That can be a better career option for you people. Because in optical communication, LEDs will be used as a source, LEDs and lasers. So all the companies that are manufacturing LEDs and lasers, that will provide you jobs if you are skilled into this area. And today in this lecture, I will tell you each and every detail that from that you can start your journey of optical communication. So LED is basically a light emitting diode. You can see it anywhere nowadays. Even in your LED screen, you will see a red kind of LED light is there. When you switch it on your LED TV, then it glows. Everywhere there are LEDs. In your bulbs that are there in your home today, there are LEDs. So you can see that how big this market is. Lasers, starting from the coils, lasers are being used for surgery purposes. Laser-based surgeries are there. Okay, laser-based communication systems are there. Laser-based weapons are there. So all the companies that are using lasers can provide you job into this area. And this is not about that this is going to be finished in few years. No, this is just the starting. We are going to move further and further into this area. Then photodetectors. If we want to use optical communication, then we need something that can convert our light into electricity. Because further, all devices that are working on electrical signals. So all the companies that are manufacturing and photo detectors, that will provide the jobs. And apart from this, the companies that are manufacturing optical fiber cables, that is a huge market for the candidates having knowledge into this area. Few of the companies I have mentioned, like Philips, Osram, Havells, all that are manufacturing these LEDs. Optical fiber, Ash Optifiber Limited, HFCL, so many companies are there in India today that are manufacturing optical fiber cables. So it means that whether you go for research, whether you go for job, in both the cases, this PPT, this lecture, this technology is going to be very important for you. Now, what is this optical fiber? Have you seen it before? Yes, you have seen it. In different trade fairs, you can see many wires that are based upon optical fibers. That is basically a thread kind of thing, a cylindrical, either of silica or of plastic. Once you put light from one end, then light will come out of the other end. So that is a very simple design cable which is hollow cylindrical, and you can see here that this is optical fiber cable, these are optical fiber cables, and all these diagrams are of optical fiber cables. I will come into detail. Now let's begin with the history of this type of communication. You have seen that in different civilizations, different things have been used for communication. Like most civilizations have used meters for communicating with other parties, have used fire beacons or smoke signals to convey their information from one end to the another end. Then, using mobile phone, you communicate through electromagnetic waves. Now, similar was there a optical telegraph that was invented by Claude Chappé in 1792 in France, and it was a simple telegraph that can transmit your information through simple optical signals. Means it can convert your optical signal into textual, you can transmit your textual information through optical signals to a different repeater, and that repeater will receive it and will again transmit it to next. So this was a simple telegraph, optical telegraph, that was invented by Claude Chappé in 1792, and it was just the beginning. So the major advancement in optical fiber communication was in 1870, when John Tyndall demonstrated his experiment of total internal reflection, and from that this optical fiber communication evolved. He just took two buckets and he showed that when water flow from upper bucket to the lower bucket through a pipe, then light will travel through this pipe in zigzag. And after that, light will come from the second end. So this was demonstrated in 1870s, and this is known to be a basis of total internal reflection. Okay, so next we come to how light wave systems evolved. Then there are different generations of light wave systems, starting from 1975 and it is up to 2020. So first generation, and we can differentiate between different generation on the basis of this BL product, means how much capacity and how much distance, how much gigabits per second, up to how much kilometers we can transmit our information. Just like in 1975, the first generation system could transmit between 1 to 10 gigabits per second. Then second generation in 1980s, it could transmit up to 100 of gigabits per second, and so on up to fourth generation and fifth generation now. So first generation, it operated near to 0.8 micrometer and used gallium arsenide semiconductor laser. Laser is a source which will convert our electrical signal into a light signal. And it has further different types. Then gallium arsenide semiconductor laser was used operating at 0.8 micrometer, and they could operate at a bit rate of 45 MB per second and allow repeater spacing of up to 10 kilometers. It means after 10 kilometers we require to repeat our signal. Then second generation in 1980s, it uses a different kind of laser, that is indium gallium arsenide phosphide semiconductor laser. In that, your bit rate was higher than the first generation, which is 1.7 gigabits per second. And now, repeater spacing was also large, that is up to 50 kilometers. Then third generation around 1985, it was operating at 1.55 micrometer and used indium gallium arsenide semiconductor laser with dispersion shifted fibers. Now they can operate up to 4 GB per second and over a distance of 100 kilometers. Then fourth generation in approx 1992. Up to that, wavelength division multiplexing was developed, in which you could transmit multiple signals through a single bundle, that is wavelength division multiplexing. Now, data transmission over 21,000 kilometers at 2.5 GB per second and over 14,300 kilometers at 5 GB per second was possible. Now, by 1996, not only transmission over this distance 11,300 at a bit rate of 5 gigabits per second had been demonstrated using the actual submarine cables. So it was a huge development with the invention of this WDM. So this is how the system was evolved. The optical fiber cables were installed in entire Europe, North America, South America, Europe, Africa, Asia and Australia. So this communication was getting very popular in entire world for communication purpose. Now the fifth generation came around 2001. So it extended the wavelength range over which a WDM system can operate simultaneously. Amplification techniques were used. We could amplify our light signal. And in 2010 experiment, a record was established when 64 terabytes per second transmission was realized over 320 kilometers using 640 WDM channels that span both the C and L bands with 12.5 GHz channel spacing. So just see, from first generation, we started from 45 MB per second up to 10 kilometers, and now we are talking about 64 terabytes per second. Okay, and we can transmit data up to 21,000 kilometers or more, and without huge spacing between repeaters. So these are the developments, and you can see that the BL product, it doubles every year. So you can see that with how much popularity this optical communication system is working in the world right now. Now let's move ahead. I hope you are getting me. So now we come to the main topic, that what is this optic transmission. So this is the fastest and most cost-effective means of high-capacity data transmission over large distances. It uses a fiber optic cable that made of glass, that made of plastic, and data transferred from transmitter end to the receiver end in the form of light. Data loss is very less if we compare with other mode of communications. In this, data loss is less up to 0.2 dB per kilometer. Now, no regeneration and amplification is required up to 10,000 kilometers. If we talk about the other way of communication, that is our electrical communication, then in that we need repeaters, we need regenerators. But here, it is required up to very huge distance. So overall cost will be less than the other systems. Now what is this optical fiber? This optical fiber is cylindrical in structure, just like a pipe, but a specially designed pipe, having different layers. It acts as a waveguide for the light. Light will travel inside it. Now, mostly glass fibers are made up of silica and we get it from sand, a special sand. But some other plastic based optical fibers are also there. Many other materials are also there other than silica, that is fluorozirconate, fluoroaluminate, and many other materials that can be used for depending upon the application. Now this is the structure of optical fiber. Here you can see that there is a 8 micrometer core, or it can be even less. This is a glass tube. Light will travel inside this only. Now outside it there is a cladding whose diameter is 125 micrometer. I am taking just example. Okay. Then outside that there is a buffer there, and outside that there is a plastic jacket. So this core, this is made up of glass or plastic having higher refractive index than the cladding. So it carries the main signal that we want to transmit from one end to the other. This cladding that has a lower refractive index than this core. Now what is this refractive index? Let me tell you here only so that you don't get confused. The refractive index tells us about how fast the light will travel through a particular medium. And every material has its own refractive index. It is a dimensionless number. So if you want to say that with how much speed light will travel through air, then air will have a refractive index. If I want to say that how fast light will travel through a diamond, then diamond has a refractive index, water has a refractive index, glass has a refractive index, plastic has a refractive index. Okay, so less will be the refractive index, more will be the speed of light into that area. Now, cladding has less refractive index than core. Then outside it, there is a buffer that protects the fiber from damage and moisture. Because light will travel inside it, so there should not be any surface contaminants that will enter this optical fiber. There should be no moisture, there should be no breakage. So that's why buffer is there. Outside it there is a jacket. Now jacket, it holds one or more fibers in a cable. Just like I showed you in my first slide, that there can be multiple optical fiber cables in one jacket. Now, the main issue is that how light will travel through optical fiber. Let's understand it. Here, let us say that this is core. Core means internal layer of optical fiber. Outside it, this is cladding. Now, cladding has less refractive index than core. So, refractive index of core is N1 and refractive index is core cladding is N2. And here is air. We know when light will travel from one medium with high refractive index to the medium with low refractive index, that will move away from the medium. So, when light will enter to this optical fiber, that it will just bend. Just like you have seen the experiment of pencil. Once you will put pencil in the water, then you will see it will bend. Then it will come to the normal point. Then let us say it is traveling from this side. So if this angle is very less, then light will move to the cladding. Okay. Now next, if we further increase this angle, then there will be a point when this light ray will further move away from the normal and it will make a 90-degree angle with the normal. Then this is this case. Now, if we further, and this case is called critical angle. Theta is equal to theta c. If the angle at which light will make a 90-degree angle with the normal, that is the critical angle. If we further increase our angle of incidence, then your ray will move further away from the normal and it will return back to the same medium. And it will keep on moving, just like, let me show you this. It will keep on moving from this optical fiber core, experiencing the total internal reflection. Okay? Now, this phenomena is very important. Otherwise, we will not get our signal from the second end, that is coming, that light is coming in the optical fiber core, and if it has to come out of the second end, then it should experience this total internal reflection. So we can define it as, if your angle of incidence is greater than the critical angle, then the light will move back to the same medium and will make a zigzag shape, reflecting again and again from core cladding boundary and will come out of the second end. This phenomena is called as total internal reflection. We can calculate it, that what should be that critical angle. Very simple. Sin theta c is equal to n2 by n1, and theta c is equal to sine inverse n2 by n1. Okay. Okay, means sine, you will take refractive index of cladding, you will take refractive index of core, you will divide it and take sine inverse of that value, you will find a critical angle. So if your theta is greater than that theta c, then your wave of light will reflect back at the same way. Now next is how many types of this optical fiber is. We can I can explain you types of optical fiber in two ways. One is depending upon the refractive index profile. Second is on the basis of how many signals can travel through optical fiber. So first is depending upon refractive index profile of the core, we can have two types of fibers. One is step index fiber and another is gradient index fiber. In step index fiber, you can see here, this is the core, this one is the core, this one is core, and this one is cladding. Okay, and that is outer jacket. Now, this has a refractive index and this has a refractive index. Refractive index of cladding is less than the core. Now, from the center of this core, if your refractive index is uniform and when it comes to core cladding boundary, there is a sharp change, a step change between refractive index of core and cladding. That is called as step index fiber. On the other side, we have a similar fiber, but here the refractive index of core will gradually decrease as we move from center of core to the cladding. That is called as gradient index fiber. This gradient index fiber has its different application. Now, second one, depending upon how many modes can travel through optical fiber. Let us say we have a single mode step index fiber. Now in that there will be only one mode that will travel through optical fiber. But if we want to make multiple modes travel through optical fiber, then we can use a multi-mode step index fiber having large core diameter than single mode fiber. Then you can see here multiple signals can travel at one time. So your light energy travels through optical fiber in the form of modes. Similarly, there can be a multi-mode gradient index fiber. In that, your multiple signals will travel at one time through your gradient index fiber. Now, let me conclude my topic with the advantages and disadvantages of optical communication system. One is large bandwidth. So, optical communication system has a huge capacity of bandwidth because with a very high data rate we can transmit signals up to very large distances. The power loss is very less in case of optical communication system. They are immune to electromagnetic interference because your signal is traveling through a optical fiber cable inside a jacket, inside cladding, inside core. So there is no chances of electromagnetic interference. Less size and weight. Security is very high because your data is there in a medium. So it is not possible for any of the other person to steal your data. Now, if there are certain advantages, then certain disadvantages also, certain limitations you can say. That cost. Cables are expensive to install but last longer than copper cables. So initial cost of setup will be more because cables are costly. But if you will see it to long term, then their age is more than the copper cables. Transmission of optical fiber requires repeating at a distant intervals. Fragile. Fibers can be broken or have transmission losses when wrapped around curves of only a few centimeter radius. So that's why you should be very careful that if you will make a bundle of optical fiber cables, then radius should not be too low. Otherwise, after certain centimeters, your total internal reflection will not take place. And once total internal reflection will not take place, then your signal will not come out of the second end. So that will be a data loss. Protection. Optical fiber requires more protection around the cable as compared to the copper. So you have to give further protection to optical fiber cables. So that was all about my today lecture on optical communication. Let me conclude it that what you have studied to this lecture. We started with what is optical communication. Then I told you that how the communication systems evolved. Then we discussed what is optical fiber, what are the job areas in optical fiber, how light will travel through optical fiber. Then what are the different types of optical fiber, structure of optical fiber, and finally I concluded with advantages and disadvantages of optical fiber. I hope you have understood this lecture. Thank you very much.